Dear students, today we are going to see what is inverse Laplace transforms in Engineering Mathematics 2, Unit 5. Definition. The inverse Laplace transform is the transformation of a Laplace transform into a function of time. If L of f of t is equal to f of s, then f of t is the inverse Laplace transform of f of s. The inverse being written as f of t is equal to L inverse f of s. The applications of inverse Laplace transform. Inverse Laplace can convert any variable domain back to the time domain or any basic domain, like from frequency domain back to time domain. These properties allow them to be used for solving and analyzing linear dynamical systems and optimization purpose. Now these are the inverse Laplace transforms. Problems. First, let us find the L inverse of 1 by s minus 3. Here we know that L inverse of 1 by s minus a is e power at. So in the place of a we are having 3. So just replace a by 3, we get L inverse of 1 by s minus 3 is equal to e power 3t. Next problem, find the L inverse of 2s by s squared minus 16. So we know that yes, L inverse of s by s squared minus a squared is equal to cos h at. So in the place of a squared we are having 16. Now L inverse of 2s by s squared minus 16 can be written as 2 into L inverse of s by s squared minus 16, which is nothing but 2 into cos h 4t. Third problem, find the L inverse of 1 by s squared plus 25. We know that L inverse of 1 by s squared plus a squared is equal to 1 by a into sin at. So in the place of a squared we are having 25. Therefore L inverse of 1 by s squared plus 25 can be written as 1 by 5 into sin 5t. Fourth problem, find the L inverse of s minus 1 by s minus 1 the whole squared plus 4. We know that L inverse of s minus a by s minus a the whole squared plus b squared is equal to e power at cos bt. Now L inverse of s minus 1 by s minus 1 the whole squared plus 2 squared can be written as, in the place of a we are having it as 1 and in the place of b we are having it as 2. So replacing we get e power t cos 2t. Next problem, find the L inverse of 1 by s minus 3 plus 1 by s plus s by s squared minus 9. So this can be written as L inverse of 1 by s minus 3 plus L inverse of 1 by s plus L inverse of s by s squared minus 9. Here L inverse of 1 by s minus 3 is nothing but e power 3t and L inverse of 1 by s is 1 and L inverse of s by s squared minus 9 is cos h 3t. Next problem, find the L inverse of 2s squared minus 4s plus 5 by s cube. This can be written as L inverse of 2 by s minus 4 by s squared plus 5 by s cube. We know that L inverse of 1 by s is equal to 1 and L inverse of 1 by s power n is equal to t power n minus 1 by n minus 1 factorial. Substituting this we get 2 of 1 minus, in the place of n we are having it as 2, so 1 by s squared is equal to t power 2 minus 1 by 2 minus 1 factorial. So we get it as t, and in the place of s power n now substitute s cube, so we get t power 3 minus 1 by 3 minus 1 factorial, that is t squared by 2 factorial. So we get 5 by 2 into t squared, that is 2 minus 4t plus 5 by 2 t squared. Next we'll find the L inverse of s by s plus 2 the whole squared plus 1. This can be written as L inverse of s plus 2 minus 2 by s plus 2 the whole squared plus 1, because we know that L inverse of s plus a by s plus a the whole squared plus b squared. So in the denominator we are having s plus 2, but in numerator we are having only s. So we are rewriting the numerator as s plus 2 minus 2. So this can be written as two terms, L inverse of s plus 2 by s plus 2 the whole squared plus 1 minus L inverse of 2 by s plus 2 the whole squared plus 1. We know that L inverse of s plus a by s plus a the whole squared plus b squared is equal to e power minus at cos bt. So the term will change as e power minus 2t into L inverse of s by s squared plus 1 minus 2 into L inverse of 1 by s plus 2 the whole squared plus 1, and e power minus 2t cos t minus 2 into e power minus 2t L inverse of 1 by s squared plus 1. So the solution is e power minus 2t cos t minus 2 e power minus 2t into sin. Next problem, find the L inverse of s minus 3 by s squared plus 4s plus 13. We know that L inverse of s plus a by s plus a the whole squared plus b squared is equal to e power minus at cos bt. So now trying to write the numerator and denominator to this form. This can be written as L inverse of s minus 3 by s squared plus 4s plus 13. We are adding plus 4 and subtracting minus 4. So that we'll be getting L inverse of s minus 3 by s squared plus 4s plus 4 plus 13 minus 4. So this s squared plus 4s plus 4 can be written as s plus 2 the whole squared, and this 13 minus 4 can be written as 9. That is nothing but L inverse of, in the numerator it will be s plus 2 minus 5, and in denominator it will be s plus 2 the whole squared plus 9, because in the denominator we are having s plus 2, so we should have in the numerator also s plus 2. So writing 3 as 2 minus 5. Now this can be written as L inverse of s plus 2 by s plus 2 the whole squared plus 3 squared minus 5 into L inverse of 1 by s plus 2 the whole squared plus 3 squared. And we know the formula that L inverse of s plus a by s plus a the whole squared plus b squared is equal to e power minus at into cos bt. So converting to that form, we'll be getting e power minus 2t L inverse of s by s squared plus 3 squared minus 5 by 3 into L inverse of 3 by s plus 2 the whole squared plus 3 squared. Since we are having 3 in the denominator, the same should be in the numerator. So multiplying and dividing by 3. So we'll be getting e power minus 2t cos 3t minus 5 by 3 into e power minus 2t L inverse of 3 by s squared plus 3 squared. So we'll be getting it as e power minus 2t cos 3t minus 5 by 3 into e power minus 2t sin t. Now let us see the next model. L of f of t is equal to s into f of s. If L of f of t is equal to f of s, then L of f dash of t is equal to s into L of f of t minus f of 0. That is, if L inverse of f of s is equal to f of t, then L inverse of s into f of s is equal to f dash of t, provided f of 0 is equal to 0. This can be written as d by dt of f of t. That is, d by dt of L inverse of capital F of. We'll see the problems related to this model. Find the L inverse of s by s squared plus 1. So we know that L inverse of 1 by s squared plus a squared is equal to sin 80. Now this L inverse of s by s squared plus 1 can be written as L inverse of s into 1 by s squared plus 1. That is of the form L inverse of s into capital F of s. So this can be written as d by dt of L inverse of 1 by s squared plus 1. So we know that L inverse of 1 by s squared plus 1 is sin t. So d by dt into sin t. Now differentiating with respect to t, we get it as cos t. Next problem, find the L inverse of s by s minus 2 the whole squared. So L inverse of s by s minus 2 the whole squared can be written as d by dt L inverse of 1 by s minus 2 the whole squared. Here d by dt into e power 2t L inverse of 1 by s squared. Now L inverse of 1 by s squared is t. So d by dt into e power 2t into t. Now differentiating with respect to t, and it is in product form. So keeping e power 2t as it is and differentiating t, will be getting it as 1, plus keeping t as it is and differentiating e power 2t, we get it as 2 into e power 2t. Now which is equal to e power 2t plus 2 into t into e power 2t. Now taking e power 2t commonly outside, we get the solution as e power 2t into 1 plus 2t. Now let's see the next problem. Find the L inverse of s by s plus 2 the whole square plus 4. So this can be written as d by dt into L inverse of 1 by s plus 2 the whole square plus 4. So d by dt into e power minus 2t into L inverse of 1 by s squared plus 2 squared. This can be written as d by dt e power minus 2t by 2 L inverse of 2 by s squared plus 2 squared, which is equal to d by dt into e power minus 2t by 2 into sin 2t, which is equal to, taking 1 by 2 outside, d by dt into e power minus 2t sin 2t. Now differentiating with respect to t with the product form, we get it as 1 by 2 into keeping e power minus 2t as it is, differentiating sin 2t, we get cos 2t into 2, plus keeping sin 2t as it is, differentiating e power minus 2t, we get minus 2 into e power minus 2t, which is equal to 1 by 2, 2 into e power minus 2t cos 2t minus sin 2t, which is equal to e power minus 2t cos 2t minus sin t. Next model is L of f of t is equal to f of s divided by s. If L of f of t is equal to f of s, then L of integral 0 to t f of t into dt is equal to 1 by s into capital F of s. That is, L inverse of 1 by s into f of s is equal to integral 0 to t f of t into dt, which is equal to integral 0 to t L inverse of f of s into dt. We'll see the proof. We know that L of f of t is equal to integral 0 to infinity e power minus st f of t into dt. Now in the place of f of t, we are going to substitute integral 0 to t f of t into dt. Now by using the integration by parts method, integral u dv is equal to uv minus integral v du, we are going to solve this integration. Here e power minus st can be written as d into e power minus st by minus s. Now here u is equal to integral 0 to t f of t into dt, and dv is equal to d of e power minus st by minus s. Now substituting in the formula, we get integral 0 to t f of t into dt e power minus st by minus s with the limit 0 to infinity minus integral 0 to infinity. Here v is e power minus st by minus s and du is f of t into dt. Now applying the limit, we get 0 minus 0 plus 1 by s into integral 0 to infinity e power minus st f of t into dt. Now we are having 1 by s into, this is nothing but L of f of t. This L of f of t can be written as capital F of s. Therefore L inverse of 1 by s f of s is equal to integral 0 to t f of t into dt, where f of t is L inverse of f of s in dt. Now problems related to this model. Find L inverse of 1 by s into s plus 3. So this can be written as integral 0 to t L inverse of 1 by s plus 3 into dt. So we know that L inverse of 1 by s plus 3 is nothing but e power minus 3t. So integral 0 to t e power minus 3t dt. Now integrating with respect to t, we get e power minus 3t by minus 3 with the limit 0 to t, which is equal to minus 1 by 3 into e power minus 3t 0 to t. Now applying the limits, minus 1 by 3 e power minus 3t minus 1, so which is equal to 1 by 3 into 1 minus e power minus 3t. Next problem, find the L inverse of s squared plus 3 by s into s squared plus 9. So this can be written as L inverse of s squared plus 9 minus 6 divided by s into s squared plus 9, because in the denominator we are having s squared plus 9. So rewriting the numerator we get s squared plus 9 minus 6, that is this 3 can be written as 9 minus 6. Now splitting this into two terms, we get L inverse of s squared plus 9 divided by s into s squared plus 9 minus 6 by s into s squared plus 9, which is equal to L inverse of 1 by s minus 6 by s into s squared plus 9. So this can be written as L inverse of 1 by s minus L inverse of 6 by s into s squared 9. So we get L inverse of 1 by s is 1 minus integral 0 to t L inverse of 6 by s squared plus 9 into dt, which is equal to 1 minus, the 6 can be written as 2 into 3 because in the denominator we are having it as 3 squared. So in the numerator also we should have it as 3. So we are splitting 6 into 2 into 3. So 1 minus 2 into integral 0 to t L inverse of 3 divided by s squared plus 3 squared into dt, which is equal to 1 minus 2 into integral 0 to t sin 3t into dt. Now integrating with respect to t, we get 1 minus 2 into minus cos 3t by 3 with the limit 0 to t, which is equal to 1 plus 2 by 3 cos 3t. And now applying the limit, we get 1 plus 2 by 3 cos 3t minus 1. Next problem. Find the L inverse of 1 by s into s plus 2 the whole cube. Here this can be written as integral 0 to t L inverse of 1 by s plus 2 the whole cube into dt. Now this s plus 2 the whole cube can be written as integral 0 to t e power minus 2t L inverse of 1 by s cube into dt. Now we know that L inverse of 1 by s cube is t squared by 2. So applying the formula, we'll be getting t squared by 2, which is equal to 1 by 2 into integral 0 to t squared e power minus 2t into dt. Now integrating with respect to t using the Bernoulli's formula, we get 1 by 2 into t squared e power minus 2t by minus 2. Now differentiating t squared, we get 2t, and integrating e power minus 2t by minus 2, we get e power minus 2t by 4. Plus now differentiating 2t, we get it as 2, and integrating e power minus 2t by 4, we get it as e power minus 2t by minus 8 with the limit 0 to t. Now applying the limit, we have 1 by 2 minus t squared e power minus 2t by 2 minus t into e power minus 2t by 2 minus e power minus 2t by minus 4. Minus applying the lower limit, we get it as 0 plus 0 minus 1 by 4, which is equal to 1 by 2 into minus t squared e power minus 2t by 2 minus e power minus 2t by 2 into t plus e power minus 2t by 4 plus 1 by 4. Now taking 4 as LCM, we get 1 by 2 into minus 2t squared e power minus 2t minus 2t e power minus 2t minus e power minus 2t plus 1 by 4. Now taking 4 outside, we get it as 1 by 8 into 1 minus 2t squared e power minus 2t minus 2t e power minus 2t minus e power minus 2t. I hope you understand the inverse Laplace transform for the elementary functions. In next video, we'll see how to solve the inverse Laplace transform using the partial fractions. Thank you.